Hello, my name is Lily Renn, and today I'm going to be teaching proofs concerning isosceles triangles. So let's start by asking, what is an isosceles triangle? Well, if you look right here, an isosceles triangle is a triangle that has at least two sides that are congruent, meaning they're the same length. Let's say we have triangle PQR here, and we're told that segment PQ is congruent to segment PR, as it's written here as well. We want to prove that angle PQR, which is right here, is congruent to angle PRQ. These two angles are the base angles of the triangle. The vertex angle is at point P, and the base is between points Q and R, right down here. And here's the vertex. So here's how we prove it. We're going to construct a second triangle inside of this one by finding the midpoint. So looking on the base, we're going to get a line, and we're going to draw right from the midpoint right here all the way up to the top of the triangle. Perfect. And I'm going to label this point S. This gives us two triangles, triangle PQS and triangle PRS. So let's look at these triangles. Segment PQ is congruent to PR, which is given. Segment QS is congruent to SR, which we just found out because this is the middle point, so these have to be congruent. We're going to draw the here, use my handwriting. And segment PS is shared, so it's congruent to itself. So we're going to show that. Perfect. This also, segment PS also shows an example of the reflexive property. So we can write that here. Since both triangles have segment PS, it reflects. Since we can see that side PQ and PR are congruent, segments QS and SR are congruent, and segments PS on both of them are congruent. This is three congruent sides. So this proves that triangle PQS and triangle PRS are congruent by using side, side, side. Because side, side, and side. So we're going to write this out. Triangle PQS is congruent to triangle PRS. And we know this because of SSS, which stand for side, 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 because they're three congruent sides. Perfect. Since these triangles are congruent, that must mean that their corresponding angles are also congruent. That means that angle PQS is congruent to angle PRS, as we can see right here, because they have the same angles. Because if these two triangles were formed into one, it would be clear to tell that angles PQR and PRQ have the same arches, meaning that these two angles are congruent, which we can write out as angle. Perfect. Now let's look at another way to prove these congruent parts in an isosceles triangle, this time starting from angles instead of sides. So let's look at a different angle. Get the pun. We're going to scroll down here, and we have another triangle. Let's label it the same. P, Q, it's ugly Q, R. And let's say we have this triangle, PQR, And this time, we want to prove that segment PQ is congruent to segment PR. So we know that these angles are already congruent. We're starting with that knowledge. We're going to write that down. We're going to do something similar, like how we drew the line up from the midpoint to the top, but this time we're going to draw from the top point all the way down to the bottom. We want this line to be going straight from point P down to the base QR. We'll call this intersection point S, similar to the first one. And we're going to write out about this constructed line. So we're going to write, and we have this here. So on ours, we constructed a segment PS, as shown there, such that PS is perpendicular to segment QR. Because for PS to be allowed to separate the triangles, it must meet with the base QR. Now we have angle Q is congruent to angle R, which is given, and we have angle QPS is congruent to angle RPS, since PS is perpendicular to QR, which makes both of these right angles, which we can show like this. Because this meets at a straight right angle, and if this side's a right angle, then this one has to be as well. So segment PS is common to both triangles. So we can write this out. Triangle PQS is congruent to triangle PRS by angle side. AAS stands for angle side, and we know this because we know that angle PQS is congruent to angle PRS, because these are the same, and we know that they both have this matching side here. Since there's two angles and one side, it's angle side. Since these two triangles are congruent, the corresponding sides PQ and PR must be congruent as well. So we can write that out. PQ is congruent to PR. Also, since segment QS and segment SR are congruent as well, as we can tell because they both have the same right angles and the same angles in the corner that are congruent, we know that S is the midpoint of QR. Like shown here, we call this one the midpoint, and we just drew this one straight down from P, but they're both the same. This one was also drawn down from P, and this one is also labeled the midpoint because it's right in the middle of both of these. They're just found in different ways. So in this case, we've proven that S is the midpoint, PS is perpendicular to the base, triangles PQS and PRS are congruent, and finally segment PQ is congruent to segment PR. So what do these proofs tell us? In an isosceles triangle, if two sides are congruent, the base angles are congruent as well. If two angles are congruent, the opposite sides are congruent as well. Both ways show how powerful triangle congruence can be when proving geometric relationships. Thank you for listening to my tutorial. This is Renn, and I hope you enjoyed proofs concerning isosceles triangles.